Bright Tuty. Every student matters.
Let us now perform a few activities once again to relate the Newton's third law of motion and the various observations made. Okay, in this activity, what we'll take is, let us take a balloon, a rubber balloon, and inflate it fully. Now, tie its neck that we tend to do using a thread, and we use an adhesive tape. Then we'll fix a straw, right, on the surface of this particular balloon. Right, with the help of this straw, what we do now is pass a thread through the straw and hold one end in your hand and fix it on the wall. Then fix it the other end on the other side of the wall. Correct. Now what we'll do is we will open up or remove the thread which is tied to the neck of this balloon. What will you observe? It will be a very good observation. You will like it. It's fun. How? That this balloon will just jump around going backwards. Now, why does it happen? It happens because this balloon was inflated. It got air inside it. So, when we just remove the thread, the air with great force, it went into the forward direction, and it will exert an equal and opposite force in the backward direction, because of which this balloon which was tied up with this straw, this will go, this straw will come to this end. This also shows that action and reaction are equal and opposite. Another activity, what we'll do is we'll just take a test tube of a good quality glass material. We'll put some water into it. Then we'll put a cork and just a stopcock at the mouth of it, and we'll tie it like this in a stand with the two strings. Now start heating this test tube. When we will start heating the test tube, the water inside the test tube is going to heat up and will be converted into steam. This steam is going to exert pressure on the cork, and after some time you will see that this cork, it just flows out. It moves out, and the moment the cork moves out, we will see that this test tube also recoils in the backward direction. Why? Because when with this force the cork moves out, it applies or exerts an equal and opposite force on the test tube, due to which the test tube will recoil, and we will see the backward motion of the test tube, and this cork is going to move in the forward direction. So all these activities relate the Newton's third law of motion. I hope now you must be in a better position. You have understood each and everything related to Newton's third law of motion. Correct? Then we have studied about law of conservation of momentum. Let us see a few numericals based on that law of conservation of momentum. Let us see. Now, a few questions. Let us see the first example. A bullet of mass 20 grams. We are given a bullet in the question. Let the mass of the bullet be m1, which is given to us to be 20 grams. Since the mass is always expressed in kilograms, we'll convert it in kilograms by dividing it with 1000. This comes out to be 0.02 grams, kilograms, because we have converted it in kilograms. Now, this bullet is horizontally fired with a velocity of 150 meter per second. The velocity, initially the bullet was in the revolver, fine, or a pistol. So the initial velocity of bullet was, let it be u1, that was 0. But after applying force by triggering by pulling the trigger, the velocity of the bullet, let it be v1, it becomes 150 meter per second. Right? From a pistol of mass 2 kilograms. Now, the mass of the pistol, let it be m2. This is given out to be 2 kilograms. Initially, the pistol was also at rest. So let the initial velocity of the pistol be represented by u2 and that will be 0. What we need to find is the recoil velocity of the pistol, that is the final velocity of the pistol. That is what we need to find in this question. Now just see this diagrammatic representation. Before the firing, the gun and the bullet inside it, they both were at a state of rest. So we have taken the initial velocity of bullet as well as the initial velocity of the pistol u1 and u2 to be 0. Right? The mass of bullet m1 is given, the mass of pistol m2 is given in the question. Right? Now the final velocity, the bullet is moving at this velocity now 150 meter per second, with which it leaves the pistol. And after firing, the gun is going to recoil back in this opposite direction. We need to find the velocity with which this 2 kilogram pistol is going to recoil. Correct? How we are going to do it? We know that as per law of conservation of momentum, the total momentum before the firing and the total momentum after firing will be same. So let us see what exactly will be the total momentum before firing the bullet. It will be equal to the initial momentum of bullet, which will be m1 into u1, plus initial momentum of the pistol, that will be m2 u2. This is equal to the total final momentum of the pistol and the bullet. The final momentum of the bullet will be given by m1 v1 and the final momentum of the pistol is given by m2 v2. Got it? Now putting the values, we know that u1 and u2 initial velocity of both is given to be 0. So both will be 0. So we can write simply 0 here. Now m1 plus v1 plus m2 and v2, they are equal to 0. Fine. This is m1 v1. Putting the values, the mass of the bullet came out to be 0.02 kilogram multiplied by its initial velocity was 150 plus mass of pistol was 2 kilogram multiplied by velocity of pistol is v2 unknown, we need to calculate. Right? So this comes out to be, I'll replace the decimal with 2 upon 100 once again, multiply by 150, 1 and 50 struck off, 1 and striking it with 3 plus 2 into v2. So 2 v2 remains here, I'll take 3 there, it will become minus 3. So v2 becomes minus 3 by 2, which comes out to be, this v2 is minus 1.5 meter per second. So this will be the final velocity of the pistol or the recoil velocity of the pistol. Got it? This minus sign, what does it indicate? It indicates that the motion of the pistol is in the opposite direction because it is recoiling, it is moving back. Got it? Fine. Let us see next question. Now, this question is quite interesting. Let us see how. We are given in the question that a girl of mass 40 kilograms. This is a girl. She is having a mass of 40 kilograms. That means in the question we are given mass of the girl. Let it be m1. That is given out to be 40 kilograms. Jumps with a horizontal velocity of 5 meters per second. So this is the initial velocity with which the girl is coming and jumping. So let the initial velocity of the girl be u1, that is given to be 5 meter per second. On to a stationary cart with frictionless wheels. Now the mass of the cart is 3 kilograms. This is the mass of the cart. That means I am given m2, assuming it to be m2, it is given to be 3 kilograms. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Now, one thing we need to remember is initially the cart was stationary. So, the initial velocity of the cart, we take it to be 0. right? Now in this particular question, we need to relate very important thing. What? That when this girl jumps over on the cart, then when the cart starts sliding or moving, the girl is still on this cart. That means the final velocity of the girl and the final velocity of the cart, that will be same, right? Because they both are moving with the same velocity. After the girl jumped onto the cart, this is the most important thing that we need to remember. Let that final velocity be commonly represented as v. v1, v2 represented as v, right? And this is what we need to calculate as to what is the velocity with which the cart is moving. And obviously when the cart is moving and the girl is on the cart, the girl also will be moving with the same velocity along with the cart. Got it? Applying the once again law of conservation of momentum, which stated that initial momentum of both the objects, which are in this case the girl and the cart, that initial momentum and the final momentum, right, will be same. The initial momentum will be m1 u1 plus m2 u2 and the final momentum will be m1 v1 plus m2 v2. Putting the values, we'll see the mass of the girl is given out to be 40. She is running with an initial velocity of 5 plus the initial velocity of cart was 0. So 3 kilogram doesn't signify, it will be 0. Then it comes out to be m1 v1. Now v1 and v2, we have seen that they have the common velocity. So we will take this v as common, which we have represented by small v, and in the bracket we will get m1 plus m2, which is given to us to be 40 plus 3, that is 43 kilograms multiplied by v. This comes out to be 200, right? So what will be v? V will be equal to 200 upon 43, of course, meters per second. So calculating it, we will get the answer to be approximately 4.6 meter per second. Got it? This is the approximate value. I am calculating it till 1 decimal place. You can calculate till 2 decimal places also, right? This is the approximate value. I repeat, I am not taking the exact values. You may calculate it. Fine. So this is the final velocity of the cart and of course the girl who was also on the cart. Got it? Right? Now let us take another example. Two hockey players of opposite teams. Fine. In the example itself, I think the students tend to use the brain as to which particular jersey color represents which particular team. No need, we'll focus on our question only. Two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. They become entangled. Now, given to us in the question is, one has a mass of 60 kilograms. This is given to be m1 and was moving with a velocity of 5 meter per second. This is his initial velocity taken to be u1. Other has a mass of 55 kilogram. The mass of other taken to be m2, 55 kilogram, and was moving faster with a velocity of 6 meter per second. This is his initial velocity, let it be u2, right? In which direction and with what velocity will they move after they become entangled? Quite importantly, because they are entangled, once again their velocities will be common. Fine. Let the velocity, the common final velocity, be v. This is the common final velocity, right? Assuming that the frictional force acting between the feet of the two players and the ground is negligible. All the information is provided to us in the question. Let us see how. Mass of the first hockey player is given to be 60 kilograms. The initial velocity of the first hockey player is given to be 5 meter per second. The mass of second hockey player is given to be 55 kilograms and the initial velocity of second hockey player is given to be 6 meter per second, right? the final velocity of both the hockey players being entangled will be same and taken to be v. Again, applying the law of conservation of momentum, we will get m1u1 plus m2u2, that is the total initial momentum before collision, will be equal to m1, that will be equal to m1 v1 plus m2 v2, that is the final momentum of both the players. Now v1 and v2 we have represented with v, so this equation can also be written as m1 u1 plus m2 u2 is equal to m1 plus m2, taking common velocity v as common, as we have taken in the above previous example. Putting the values now, mass of the first player is given to be 60, multiply by 5 plus m2 is 55, multiply by 6 will be equal to, I'll take 55 plus 60 into v. This comes out to be 300, right? Plus this comes out to be 330 is equal to, this comes out to be 115 v. So this is 630 is equal to 115 v. Putting v on this side and taking 115 over there comes out to be 630 upon 115. Correct? This will be in meters per second, of course, right? Let us calculate. If we'll just strike it off with 5, I'm cutting it off. 5 1 the, 5 2 the, and 5 6 the. Here I'll get 523, right? Now dividing it, the value of v will come out to be 6.2 meter per second approximately. So this will be the final velocity of these two hockey players. And in which direction they will be moving? They will be moving in the direction in which the player B, who was with greater velocity, who was basically moving. Right? Fine. So this is some questions based on law of conservation of momentum. Fine. I hope you have understood the basic concept of law of conservation of momentum, and please try to practice the numericals. Right? This is all about our force and laws of motion, the theoretical part. Now there will be few numericals of the back exercises that we'll be discussing. Take into consideration all the numericals, all the formula that we have done till now, so that we have all the basic concepts ready for doing the back questions. Fine. Thank you so much. Take care.